Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, we're going to introduce to you DeMoivre's theorem. The DeMoivre's theorem is named after Abraham DeMoivre. So we'll start by writing down a complex number. So let r times cosine theta plus I sine theta be a complex number, and so this complex number is written in polar form, which is also called trig form. An alternative for this notation would be r cis theta, so that would be an alternative for this notation. And another alternative, if you're familiar with it, would be r e to the I theta. So both of these are also acceptable substitutes for everything that follows. Then, for any positive integer n, we have the following. We can raise this complex number to a power in a very convenient way. So I'm going to use a different color here, and I'm going to write down all three varieties so you can see how all of these are applied. The first one, I'll use a bracket here, bracket r cosine theta plus I sine theta, parentheses, and then bracket. So if you raise this to the nth power, you basically raise the r to the nth power, and then the n goes inside the trig functions like this, cosine of n theta. It's pretty cool. Plus I sine n theta. Really cool theorem, I think so. Really powerful. We'll do an example in a minute. It's actually really simple to use. Alternatively, if we use the cis notation, otherwise cis stands for cosine I sine, this would be bracket r cis theta. I guess I don't need the parentheses there. Let me get rid of that. Since it's just cis, it makes it a little bit cleaner. It's cis theta, and again, we're raising this to the nth power. You get r to the n cis n theta. Okay, and just to be really clear, to make sure there's no confusion, what is cis theta? So cis theta, maybe I'll write it up here, cis theta is cosine I sine. So it's cosine theta plus I sine theta. So it's exactly the same thing as what you see here. So this is cis. Likewise, this is also equal to e to the I theta. So same thing, right? Same thing. All of these are exactly the same. So continuing here with DeMoivre's, let's write it down using this exponential notation. So we have r e to the I theta, and that's being raised to the nth power. And this would be r to the n e to the I n theta. And this makes more sense for a lot of people. You're basically exponentiating the e, right? N times I theta is, n times I theta, which is right here, n times I theta. So algebraically, this is the one that makes the most sense for people. So all three of these are considered DeMoivre's theorem. So let's go ahead and just do a simple example of using DeMoivre's theorem to raise a complex number to a power. And typically when you do these, like in a classroom setting, they always say don't use a calculator, do it by hand, show all your work. But it's pretty simple. So let's start maybe with this one. Say we have bracket 3, parentheses, cosine, and let's do 3 pi over 4. So 3 pi over 4 plus I sine 3 pi over 4, parentheses, and then I guess we need one more parentheses here, all right, to match this one here, and then a bracket, and we're going to raise this to the 4th power. Okay, we're going to go to the 4th power this time. All right, let's go ahead and go through it. So the solution, pretty easy. All we do is, using the formula, we raise the r, right? This is our r. Oops, this is our r. So that will be 3 to the 4th. And then the 4 goes inside the trig functions. So it'll be cosine of 4 times 3 pi over 4. That's your n. Plus I sine of 4 times 3 pi over 4. Okay, just like that. And let me just show you the formula up here just so you can see we're using it correctly. So it's r to the n, and then cosine n theta, I sine n theta. So it's 3 to the n is 4 here. Cosine n theta, so n is 4, theta is 3 pi over 4. I sine n theta, n is 4, theta is 3 pi over 4. So very simple. So now we can clean this up. We can cancel these 4s. 3 to the 4th is 81. That's because it's 3 squared times 3 squared, which is 9 times 9, which is 81. So pretty simple. It's 81. Then we get the cosine of 3 pi plus I sine of 3 pi. So to figure out what the cosine of 3 pi is and what the sine of 3 pi is, what we can do is think about the unit circle. So I'll draw a picture here. Here's the unit circle. The unit circle is a circle of radius 1 centered at the origin. And the unit circle is special because every ordered pair on the unit circle has the form cosine theta comma sine theta. So here, this is 0, but it's also 2 pi. So to get to 3 pi, you do one complete revolution, and then you go one more half revolution. So this would be 3 pi, which is also pi. So we want the ordered pair here. Well, because it's the unit circle, this distance here is 1. So the x-coordinate is -1. And you can see here we're on the x-axis. So we're going up by 0. So the y-coordinate is 1. Cosine is the x-coordinate on the unit circle. So cosine of 3 pi would be -1 because that's the x-coordinate. So this is 81 times -1 plus I times, and then sine of 3 pi would be the y-coordinate at 3 pi, which is 0. So this is just 0. So we get 81 times -1 plus 0, and so we get the answer of -81, which is really, really nice. So that's how you use DeMoivre's theorem. And yeah, it's pretty simple. All you do, again, is you just raise r, this is your r, to this power, and then you just put the number inside the trig functions, and then you clean it up. And after that, you're good to go. Remember, r is called the modulus, and theta is called the argument of the complex number. Thanks for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.